Hi, I'm Scott Novick.
I'm David Eagleman, and this is my neuroscience laboratory.
And we're changing the way brains read information from the world.
There are 50 million people worldwide who have deafness. And right now, the only available technology is the cochlear implant.
The challenge with cochlear implants is that they don't always work for everybody. They're expensive, they require an invasive surgery, and if you're born deaf and you get one too late, they don't tend to work very well.
With this project, we're hoping to change that. In 1969, a scientist named Paul Bach-y-Rita put people in a dental chair, and there was a video camera, and the video feed fed into the back of the dental chair. So you put a circle in front of the camera and you feel the circle in your back. And what he found is that blind people were able to come to understand what was in front of the camera by the skin of their lower back.
So sensory substitution is the idea of taking information from one sense and feeding it into another sense.
So how could this be applied to hearing?
Our sensory substitution device is this V.E.S.T. And the way this V.E.S.T. works is that sound from the environment is taken in through your smartphone. And the smartphone takes care of all the sorts of signal processing that goes on with the audio signal.
And sound from the environment gets converted into patterns of vibration on the skin. And the idea is the brain gets the information from the torso and can figure out how to interpret that information.
Our device is actually pretty similar to a cochlear implant. At the end of the day, both are actually just sending electrical signals into the brain just through different pathways. So we estimate that our device will cost the consumer less than $2,000. A cochlear implant, on the other hand, has a lower bounded cost of about $40,000.
Because of its cost, we can disseminate this solution to people around the world who otherwise couldn't afford surgery. When you first put the V.E.S.T. on, there are patterns of vibration that are difficult to interpret. But through training, one becomes very good at understanding what is being felt on the skin. And after 2 weeks, this should transition into a direct perceptual experience.
This sensory substitution project will be the kind of highest throughput example of sensory substitution to date. We're really pushing the limits in terms of how much information we can send through the human body. With this project being successful, this will open up the door to a whole new market of really neat sensory devices and ways of feeding cool, atypical information into people.
This understanding of the brain opens new worlds of possibility. This will be a cheap, non-invasive solution they can wear under their clothing, and it'll change our concept of sensory perception.
We hope you join us on this awesome journey of science.
Thank you very much for watching our Kickstarter video. You're going to help us bring this project from the laboratory into the real world.